So we're going to be getting into slope here, right? And the best thing I can think of that you guys could relate to with slope would probably be something like this: miles per hour. Okay? You guys know if you're traveling in a car or vehicle, it's always in miles per hour. And we always put time on the x-axis, so that would be hours, right? And then whatever other unit we're measuring would go on the y-axis. So keep that in mind, because it's going to come up like which one goes on top, which one goes on the bottom, and this is a good way to figure it out. So time is always on the x-axis. Sometimes instead of x, they'll put a t for time. And you'll notice this in science. Every time you're measuring something, doing some experiment, time is always down here. They might even say it's called the independent variable, and they have some other fancy names for it. But just keep that in mind, because the number one mistake for the slope and rate of change is really which one's on top, which one's on the bottom. So if it helps you, just think about the miles is it's on the y-axis, and the time is always on the x-axis. And from here on out, it'll help us know which one goes where. All right. So we were calculating slopes before yesterday. And you guys put in y equals mx plus b, right? A whole bunch of different numbers. Okay. And you saw that if you change the slope, it makes it steeper. And negative makes it go down, and positive is up. And what's in the middle of going up and going down is 0. So a horizontal line was just a 0 slope. So that's the big idea from yesterday on that first page, is that the slope controls where it's going. But how do you figure out where it's starting from? That's what the other number is for, the y-intercept. The y-intercept, which is right here, where it crosses the y-axis, there you go, will show us where the line starts. So in order to have a line, you have to have two things. Where is it starting from? That's the y-intercept. And where is it going? That's the slope. Okay? And whenever you're calculating any word problem or anything like that, those are two things you need to know to find the answer. If you want to find out how long it takes to get Las Vegas, you need to know two things. Where are you starting from? What city, what state, and how fast you're going. That's the slope. So it makes sense that you always need those two pieces of information to solve any problem, slope and y-intercept. And the slope is also called speed, rate of change, so many different things depending on what you're doing. In science, they call it other things as well. So here's what we're going to do. We're going to look at some actual real-life things for your assignment, and just figure out what the slope is by deduction. Okay? So the first few, it actually just gives you the graph already. You just have to know that, okay, the answer is going to be here, and we usually put m equals for slope. It's going to be centimeters over time, which is days. The D stands for days. So, and you just need to figure out what the numbers are. But the first part is kind of like which one goes on top, which one goes on the bottom. And if it's easier for you, just remember the y-axis is always on top, like miles, distance, right? And then per hour, time is always on the bottom. And then we can just look at the chart, and from here we can see, like, okay, from basically what do you have to do to get from this point to this point? We have to go up how much? Okay, so if we go up this much, how much is it? Okay. Or actually, it might be easier to just go up here. So let's go from here to here. So from here to here, how much do we have to go up? Right. From here to here, it's up 5. So 5 centimeters. And then from here to here, you can see the numbers down here. It's going to be 4 days. Right. And that's your slope, 5 over 4. On the Desmos, it's a decimal, but most of the time we just want a fraction, because we can go back and actually graph it easier when it's a fraction. So in general, do not convert anything to a decimal unless you have a very good reason to. But especially with anything divided by 3 will come out to a repeating decimal, which is not the same as the fraction. All right, so same thing here. Get the units right first. So we know it's going to be dollars over hours. that right. And then we can look at the graph. Now you noticed last time I just picked 2 points. It doesn't matter which ones you pick. You get the same answer because it's going the same speed. It's going the same thing. That's why it's a straight line. So if it's not easy to pick the 2 that are closest to each other, you can pick the 2 that are furthest from each other and just reduce the fraction. It's the same fraction. So we have this would be 15 right here. So again, this is going to be up 5, right? So it's $5 over 1 hour for every hour. Now, when it's a 1 on the bottom, that's when we say per hour. So this is $5 per hour when there's a 1 on the bottom. So you'll hear that said a lot. But if there's like a number on the bottom, then we just say, oh, 5 centimeters in 4 days, per 4 days. Right? So that's the idea that you're going to do on all of these, but on the next ones you actually have to come up with the graph on your own. You have to plot the points yourself just by the situation they give you, which is pretty straightforward. You guys can probably do this pretty easily. If it's easier for you to do the graph first and then the table, then you can do that, but most will find the table easier. Then you can plot the points and then just do what we did on number 1 and 2, and you'll get the slope. So it's very it describes it very well on the problem too. It tells you exactly age is X. So when you have the X column here, put age. So it's very not ambiguous at all. So dollars in the piggy bank is Y. So Y, you can put dollars. There's no question about which one goes where, what column, and all that good stuff. Okay. So let's go ahead and read this and try one out. So Zoe's grandmother put $20 in the piggy bank when he was born. So that'd be at age 0. We have $20. After each year of Zoe's birthday, grandmother deposited $20 more. So at 1 year old, how much money does she have? $40. And at 2 years old? $60. Now, after a while, you can just follow the pattern, right? It's going to go up or down the same amount every time. This is what makes it a straight line. If these weren't the same number, you would not have a straight line. So the fact that it's consistent on both sides, right? It's going up by 1 for each of the ages, right? Going up 1 age, and going up by $20. That's what makes it a straight line, right? And then we just go ahead and plot these points. So we're going to start off at $20, and then at 1 year, $40, and you can see it just, yeah, straight line. And just like the last homework or Tuesday's homework, if it's not a straight line, something is wrong. Don't just go ahead and, zigzag it and connect them. There's something wrong, okay? They should be there. Okay, now question, is this a discrete or continuous situation? Okay? So at any point, does she have $25 or $30 or $37.50? No, it just goes from 20 to 40 to 60. So this is discrete, and you do not want to draw a line through it. So this is the important reason why we know continuous from discrete, because a line would assume, if we put a line through it, it would mean that these are all points as well, but we can't have all these. We're just doing, when born $20, 365 days later, it jumps to 40. There's no in between of $20 and $40. Okay. So don't want to do that. It's not going on. All right. So don't connect. And then we can do the slope. And we have dollars here. We got age here, or years. So we can put dollars and age. Okay. So go ahead and do as many of those as you can, and we'll go over a little bit more. We'll have some time beginning of Monday to finish it up. So don't worry if you can't get them all done. There's quite a few of them. Okay.